Okay, so verifying trigonometric identities by multiplying by the conjugate. So we're asked to verify that sine of theta divided by 1 minus cosine of theta is equal to cosecant theta plus cotangent theta. So we're going to choose the left-hand side because that has a fraction, so it is more complicated. So what can we do? Well, if we multiply by the denominator, but the conjugate of the denominator, we're going to multiply by 1 plus cosine of x, or cosine theta. So if we do that, we'll have sine of theta multiplied by 1 cosine of theta. And then on the bottom, 1 multiplied, so we'll have 1 minus cosine squared theta. Now we know from the Pythagorean identities that 1 minus cosine squared theta is equal to sine squared theta. So we can change this to sine theta 1 plus cosine theta is divided by sine squared theta. And this is because 1 minus cosine squared theta is equal to sine squared theta, which is the Pythagorean identity. So now we can simplify. So one of these will be gone. So we have 1 plus cosine theta over sine theta. So what I'm going to do now is write these as separate fractions. So 1 over sine theta plus cosine theta over sine theta. Now we know that cosine theta over sine theta is equal to cotangent of theta. And we know, so let's change that to cotangent theta. And we know that 1 over sine theta is equal to cosecant of theta. So we can change that. So if we look at our final answer, cosecant theta plus cotangent of theta, we have proved that the left-hand side is equal to the right-hand side. Okay, so we have another question. Verify that tan x divided by secant of x plus 1 is equal to cosecant x minus cotangent of x. So the left-hand side is a little bit more complicated, so we're going to use that one. So we're going to multiply by the conjugate of the denominator. So we have tan of x over secant x plus 1. And we're going to multiply by secant x minus 1. So if we multiply those out, so I'm just going to leave that on the top as it is for a second, and then on the bottom, so this is going to become 1 minus secant squared of x, and then our Pythagorean identities, they tell us that 1 minus secant squared theta is equal to tan squared theta, or in this case x. So we're going to rewrite. So we've got tan x secant x minus 1. This is going to be divided by tan squared of x. So now we can simplify one of the tans. So this is going to leave us with secant x minus 1 divided by tan of x. So if we rewrite them both over as separate fractions, we'll have secant of x over tan of x and minus 1 over tan of x. So what do we know about these? Well, secant of x, this is 1 over cosine, and tan of x, this is sine of x over cosine of x. And 1 over tan of x, this is cotangent of x. So let's have a look what we can do. So if we rewrite secant, so this is going to be 1 over cosine of x divided by sine of x over cosine of x, and then this is minus cotangent. So let's have a look. If we multiply both of these by cosine of x, the cosines will cancel, and then we're left with 1 over sine of x. Now we know 1 over sine of x is equal to cosecant of x. So this is cosecant of x minus cotangent of x. And if we look at the question, we have cosecant of x minus cotangent of x. So cosecant of x minus cotangent of x. So we have proved that the left-hand side is equal to the right-hand side.